In this section, we'll look at data models, vector versus raster data. Vector and raster data are part of data models. A data model organizes data elements and standardizes how they relate to one another. Data consist of symbols that represent measurements. Geographic data measure representative samples of locations, since not every possible location can be represented in a data set. Here's the basic problem. There's an infinite number of possibilities of features that could be included in a geographic data set, but we can't represent everything. So we simplify things. We make decisions about then how we symbolize that data. These data models represent two different strategies for symbolizing the data that we're selecting to display. Vector and raster are two different ways of representing geographic data and defining relationships between and among data elements. Vector uses point sampling to represent attributes. Raster data samples attributes through a grid cell approach. Here's an example of vector. The feature is sampled using points, which are then aggregated into either points, lines, or polygons. In this case, we can see an aerial photograph of a reservoir and a road. In order to map out that reservoir and road, we could do it through a couple of different means. In this case, this is symbolized through vector data model. The small squares are nodes. These are points that are used to create the feature representation. It's most likely that this line on here that represents a road was created through on-screen digitizing, which means that someone entered data by basically creating a line by following the pattern of the road, and the same for the reservoir to create a polygon. So the reservoir is represented as a polygon, and the road is represented as a line. The nodes are the points that are used to then create the feature representation. There are all kinds of decisions that have to go into how many nodes need to be placed in the line or in the polygon in order to truly and accurately represent that feature. And that will be the subject of much consideration in later labs. As we look at vector data, map features are mapped out as points, lines, or polygons. Vector data is well suited to mapping entities with well-defined edges. For example, well sites, roads, parcels, rivers, and political boundaries. The feature attributes then look like the table below. The data you've been working with in your lab has almost all been vector data, where you see that point, line, or polygon symbol below the layer name. So you can see here the examples of an attribute table that shows shape, the name of the city, the class that the city is in, the population in 2000, and the state. So raster data, by comparison with vector data, samples attributes to a fixed size and represents them as grid cells. The area covered by the aerial photograph has been divided into a grid. Raster cells are often used to represent continuous data that lacks well-defined edges. Imagery is a good example of the use of raster data. Each cell is a pixel in the data set. The cells are assigned the value for the feature they represent, either road or reservoir. The reservoir is represented by grid cells. The road is represented by grid cells as well. Notice that this has a grid cell shape, and it has a completely different appearance from the vector data. The purpose of the data, or of the project that one is working on, needs to be considered when you decide what type of data to use, because you have choices of converting back and forth between vector and raster data, and there are multiple things that have to be considered when those conversions are done. So in this case, we're simplifying continuous data and basically using grid cells to represent features that might be best represented in this case in a raster data format. And again, the purpose of the project will determine how it is that you will choose your data model. Raster cells are composed of rectangular grid cells. Each cell is a pixel. Each cell has a cell value, which is used to represent data and may be symbolized as a color. In this example, we had a categorical example, where we might have 1 equaling road and 2 equaling reservoir. We could have a numerical example where a cell value relates to the brightness in an image. So for example, the reservoir in the previous image was very dark. It would have a lower cell value. And the land around it, or the road feature, might have a much higher cell value. That's another way that those cell values can be determined and classified and used in data. And that concludes a brief overview of vector and raster data.